In this video, I would like to talk about two more definitions. The first being disjoint or mutually exclusive events. Some books use the term disjoint and other books use mutually exclusive. I like mutually exclusive better because it describes basically better what they are. And basically what that means is that they have no common outcomes. Okay, so and these diagrams describe it really well. So mutually exclusive events do not overlap. Okay, these events are not mutually exclusive or not disjoint in this diagram. So an example of two mutually exclusive events would be when rolling a die, getting an even number. That's one event. And the second event would be getting a 3 when rolling a die. Those events are mutually exclusive. They don't have overlapping parts. Now, rolling a die and getting an even number and rolling a 4 would be not mutually exclusive because 4 is both, satisfies the first event and the second event. So it is an overlapping part. Another example of events that are not mutually exclusive would be to have a rainy day and a rainbow, right? Not mutually exclusive, it happens at the same time. Have you seen it raining and also the sun out? Again, not mutually exclusive. Now, to have a daylight and pitch dark would be mutually exclusive because it's either one or the other and not together. Okay, so here's some examples. We have an experiment tossing 2 coins. This is our sample space that we already seen. Event A is getting 2 heads or a head and a tail. Event B would be getting both heads or both tails. And event C is just 2 tails. The question is, determine which events are mutually exclusive. Well, and so the question is, do they overlap or not? Mutually exclusive events do not overlap. So if you look at event A and B, they have one element that's common for both of them. So they're not mutually exclusive. For events B and C, again, we have 2 that are overlapping. So they're not, one that's overlapping. Again, they're not mutually exclusive. But if you look at events A and C, they don't have any common elements. So they don't overlap and therefore they are mutually exclusive. And here's some facts about mutually exclusive events. Since they don't overlap, then the probability of A and B will always be 0 since they don't overlap. We can also write it like this. And also any event A and its complement, they're always mutually exclusive, again, because they don't overlap. So here's some examples that you can see. The aces and kings are mutually exclusive because aces don't have any kings and kings don't overlap with aces, right? Now, if we look at all the hearts and kings, those events are not mutually exclusive, not disjoint. Why? Because they have one element that they share, king of hearts. It belongs to both sets. It belongs to hearts and kings. So that those 2 events are not mutually exclusive. Okay, some special rules for mutually exclusive events that we already looked at. So first of all, the addition rule, when we are looking for probability of A or B, remember we said it's probability of A plus probability of B minus the probability of A and B. Well, if A and B are mutually exclusive, then this probability is 0, according to the previous slide. And so our addition rule just simplifies to probability of A plus probability of B. Again, as a reminder, please remember that it simplifies to this only when events are mutually exclusive. If they're not, the full addition rule still works. Okay, for conditional probability, again, the probability of A and B is 0. So the probability of A given B becomes 0 when A and B are mutually exclusive.